After we define the interface for our microservice, we can start implementing microservice components. And the first components we are going to build is related to persistence. In production, we are going to use MongoDB NoSQL database. But for unit testing and other test scenarios, we are going to build a few more persistent components that will store data in memory or in file. That will allow us to cut dependencies on external services. Doesn't matter what persistent storage we are using, we want to make sure that all those components behave identically. To ensure that, we will implement a reusable test suite in Beacon's persistence fixture class, and then reuse that suite in our automated test for each persistent component. Under source folder, create persistence folder. There we will place our persistence components. Let's start with defining interface for our persistence. It will have a few methods. Get page by filter, where we are passing filter parameters and paging parameters, and method return a page with beacons. Get one by ID, get one by UDI, create, update and delete operations. As you may notice, this interface is very similar to the controller interface, but we use slightly different naming conventions. The reason is that persistence components process single business entity, and simple methods will allow us to reuse methods from the abstract implementation. On the other hand, controllers may process different business entities, and for that reason we need to give them more specific names by including entity name into the method name. So in that case we'll have create beacon, update beacon, delete beacon. Then the first persistence component will be memory persistence. This component will be used mostly in automated unit tests. We are going to use abstract implementation from Pip.Services that's called identifiable memory persistence. That persistence knows how to create basic crude operations for objects that have identifiable field or simply ID field. Most of the operations will come from the base class. We just need to override a getPageByFilter method and provide a filter function. In the filter function, we're going to get filter parameters, extract filter parameters from there. So in this case, we'll be filtering by ID, site ID, label, UDI, or list of UDIs. And we'll return a filter function that will compare past parameters if they're set with values in the objects. And if all filters passing, then it will return true to include objects into the result set and false to exclude it. And then we will implement a custom persistence method, getOneByUDI, because this method doesn't exist in the base implementation. We are going to filter our objects stored in the _items property field, find object by UDI, log message into the logger, and then return the found object. To implement file persistence, we'll be just using our memory persistence and setting persister object. Persister object will allow us to save data and load data into the memory, and we'll reuse all other methods from the memory persistence. MongoDB persistence will use abstract implementation from Pip.Services toolkit called identifiable MongoDB persistence. In the constructor, we'll define collection name that's called beacons. We'll get to override a getPageByFilter method by providing filter object. Similar to memory persistence, we are going to receive filter parameters, extract parameters from the filter, and if it's set, we will identify matching criteria for ID, site ID, label, UDI, and list of UDIs. We're also going to implement a custom persistent method, getOneByUDI. We'll be using _collection property, that's the property from MongoDB driver, and call findOne method passing UDI as a criteria. This method will return a callback with error of found item. So we get to convert it into a promise, convert an object that we received from MongoDB into the public implementation. By default, this method just replaces _ID with ID field and return it as a result of this method. In similar way, you can define any other custom persistent method that you need in your persistence. After we completed our persistence components, we need to write automated tests to test them. Let's create persistence folder under test folder, and here we'll place our automated tests. Doesn't matter what persistent technology we are using, whether we store data in MongoDB or in memory in flat files, all the persistent components must have identical behavior. To ensure that, we'll implement the reusable test suite and place it in the beacons persistence fixture class. This class will receive persistence as a parameter, and then it will have a few reusable test methods. Test create beacons will create 3 predefined beacon objects, and after it created it, it will receive the result create operations and check that it matches the original beacon. It does it for the first beacon, second beacon, and the third beacon. The second test method, called test Crude Operations, it will create 3 beacons. After that, it will try to get all beacons using empty filter criteria, and at the end we will test that the page will return exactly 3 objects. We will get the first object, change the human readable label, and call update operation. After the update, we check that the result has the updated label field. The next method will be getOneByUDI. We'll be passing UDI, and we will check that the return object matches the object that we requested. Then we are going to delete beacon and try to get the deleted beacon. Since this object uses physical deletion, we should receive an empty object as a result. The second test operation will test different filter parameters. We will create 3 beacons, and then we'll try to retrieve them by ID, UDI, list of UDIs, or site ID. And we will check that we receive the correct number of beacons that satisfy that filter criteria. Now let's create tests for memory persistence. In this test, in the setup method, we are going to create an instance of the persistence component, call configure method with empty configuration parameters, create fixture class and pass reference to the persistence, and then we'll open persistence. In teardown method, we are going to close persistent component, and then we will delegate 2 tests to the fixture that we just created. Tests for file persistence will look very similar. We'll create instance of the file persistence component. In the configuration, we'll pass path parameter that points to the data folder and beacons.test.json file name. Then we'll create fixture, open, and then we'll clear persistence, because this persistence components will save data on disk. And once we create a new instance of the object, it will automatically load data from the previous test. So we need to start with a clean sheet and remove all the data from the file. In the teardown, we are going to close the persistence component, and we will delegate test to the same fixture to make sure that all operations executed identically. MongoDB persistence test will look very similar, but here we are going to read configuration parameters from environment variables. We do that to make sure that we can run our automated tests inside Docker container, and we can configure the correct connection strings. But as you see, by default, we point to the local host. That will allow us to ensure that when we start these tests and we set up all the infrastructure, the developer doesn't need to configure anything. By default, it will run against default configuration that is running on his development machine. That helps a lot with onboarding new developers. In the setup method, we will create an instance of MongoDB persistence component, and in the configure method, we'll pass configurations with connection URI, connection host and port, and name of the MongoDB database. Then we'll create fixture class with reusable test suite. We will open persistence and we'll clear any data that is stored in the MongoDB. So we can start with empty data set. In the teardown method, we are going to close the persistence and we'll delegate execution of the test to the same fixture. So all our tests will have similar test suite to ensure identical behavior across all persistence components. Then, in order to execute these tests, we need to have a running instance of MongoDB server. As you remember, prerequisites for this video was only Node.js and Docker. So we are going to run all our dependencies, including MongoDB database, inside Docker. To do that, under Docker folder, let's create docker-compose.dev YAML file. By our naming conventions, this file will be used to set up all the required dependencies for the development. And as you see here, I have MongoDB container configured and mapped ports to the local host. So our configuration in the MongoDB persistence test will point to this running container. It will be available through localhost post 27 or 17. Now let's start a new terminal and start MongoDB using Docker Compose. We'll run Docker Compose -f docker dev and then up and -d command that will start this Docker component as a daemon. So now we can see that Docker is up and running. We have MongoDB instance available. Now we can compile our code. The compilation was successful, and then we can execute unit tests by calling npm test command. As you can see, all tests executed successfully, a test for file persistence, memory persistence, and MongoDB persistence. After we have persistence components, we can start working on the business logic for our microservice.